In the name of God. Hello, dear students. Welcome back to Ferho's website. We are at your service to explain physics curriculum, grade 12. So far, we talked about, we explained one lecture from chapter 1, which was about the rotational motion and circular motion. We focused on some expressions have to do with the rotational and circular motion. You have to concentrate on these expressions for describing our motion. And the most important factor that I want you to concentrate on it is angle of rotation, because angle of rotation is the way to understanding the motion, is the way to describing the rotational and circular motion, right? Angle of rotation. And beside angle of rotation, we have radius of circular path and arc length. I want you to focus on these, three factors. They are significant for our understanding of these types of motion. Right now, I'm gonna complete our lecture by solving or by answering some questions here. Let me read the question number 1 for you. I'm gonna discuss it with you, right? I didn't answer these questions. I answered them here, in front of your eyes, and I want you to think about the answer and guess the answer before let's underline or circle the answer. Question number 1. When an object spins, I told you, spin means rotate, right? Spin and rotate have the same meaning. Rotation or spinning is the same meaning, right? When an object rotates, right? It's said to undergo space motion. When an object rotates or spins, it's said actually that the object undergoes what? Rotational or circular motion? I'm sure you know the answer. Rotational motion, because spin means rotation, so rotational motion. Number 2, space is the line about which the rotation occurs. It's the line, let's say, about which the rotations occur. Think about it. What's this line? Is it reference line? Is it axis of rotation, radius of circle, or rotational motion? It's a line about which the rotation occurs, right? It's the axis of rotation. Axis of rotation, it's clear from its name, right? It's a line about which the rotation occurs. It's called axis of rotation. Number 3, it's the line perpendicular to the side of the spinning object. It's perpendicular to the side of it and passes through the center of the object. So what's this? Is it reference line? Is it axis of rotation, radius of a circle, or rotational motion? Actually, because it says line perpendicular to the side of the object, so it's the same thing, axis of rotation. So the answer of these questions, question number 2 and 3, is the same, right? It has 2 definitions. Whether you say axis of rotation is the line about which the rotation occurs, or you say it's a line perpendicular to the side of the object and passes through the center of the object, it doesn't matter, right? It's the same. So answer of these questions are, is one thing, which is axis of rotation. Question number 4. A point on an object, right? A point that rotates about a single axis undergoes a point. So focus on one point. I say a point. I don't say the entire object. A point on a rotating object, right? Undergoes what? Undergoes a space motion. So I want you to fill the gap for me around that axis. A point, think about the blades of the ceiling fan. Think about for example, the wing of this pinwheel, right? The wing. This wing let's say, so this point or this wing, does this wing or one wing rotate about the axis or circles the axis, right? So one point or one part of the object, one segment of the rotating object has circular motion, not rotational motion, right? So the answer is circular motion. Let me circle it for you. Question number 5. According to the figure, we have a figure here, right? There's a figure. According to the figure, the direction of motion in a circular path is, look here, let me explain for you, right? We have a figure here. This figure, let's say, actually describes what? This figure describes the motion of an object that travels along a circular path. Maybe this object is a car that travels, let's say, along a square, or maybe it's a light bulb on a merry-go-round or Ferris wheel or anything, right? So there's an object. The object rotates about the circular path. So what's the question? What does it say? Right? It says, according to the figure, the direction of motion in a circular path is the direction of motion constant or constantly changing? Look here. Determine the direction of the object here. Upward, right? The object, after a while, right, after a time interval, reaches here. Determine the direction of object here, to the right. So it changes the direction. After another time interval, it reaches here, right? It changes its position. Tell me the direction of the object, the same object actually, that circles the circular path. Here it points downward. It reaches here and it points, let's say, to the left. That's why the direction of the object, let's say in a circular path, is constantly changing, right? Because the direction of the object in a circular path is constantly changing. That's why kinematic equations, right? If you remember kinematic equations, we had 4 equations for linear motion, and these equations actually are called kinematic equation. Kinematic equations are not used in a circular path because of this reason. Because the direction of motion in a circular path is constantly changing, right? So, which option is right? This one. Let me circle it for you. This option is right. Constantly changing. Right. Let me ask you a question before I move on to the question number 6. Maybe you say, teacher, you say that the kinematic equation is not used here. Kinematic equations don't work in circular motion. So what's the alternative, right, for these equations? The alternative for these equations is the edit of the kinematic equation. Edit. We have to, let's say, we have to enter some new, let's say, quantities instead of the velocity, instead of the acceleration. God willing, in next lecture, we got information about it, and we make the kinematic equations. Actually, we will update the kinematic equations. But till now, keep in mind that kinematic equations don't work in circular motion. Why? Because in circular motion, direction of the object is constantly changing, and kinematic equation only works, actually every kinematic equation works only in let's say one direction, not in let's say more than one direction. That's why it doesn't work here. Question number 6. All points on a rigid rotating object. I'm sure you know the answer because I explained it for you. I elaborated that for you actually in the previous lecture. All points on a rigid rotating object move with, we have a gap here, move with angle except the points that are located on the axis of rotation. So all points on the rigid rotating object move with the different or with the same, actually. I'm sure you know the answer, with the same. And there's an exception here. Exception is dedicated only for what? For the points that are located along the axis of rotation. Question number 7. Ferris wheel moves around an axis, experiences Ferris wheel thoroughly, right? I didn't mention, question does not mention, for example, a point on a Ferris wheel, or it doesn't mention a bulb, light bulb on a Ferris wheel, or a participant actually in this, let's say, play. It says, Ferris wheel thoroughly moves around an axis, experiences which type of motion? Fill the gap for me. Does it experience rotational or circular? Actually, because it says the entire Ferris wheel, that's why the answer will be rotational, not circular motion. Question number 8. Let me bring it up for you. Question number 8. It says, question number 8. A light bulb on a spinning Ferris wheel. You see, it's a light bulb. A light bulb. It determines a particular point, right? It's a light bulb. One, let's say, segment. It takes only one segment, one point, one part. A light bulb on a spinning Ferris wheel undergoes motion. Which type of motion? Actually, fill the gap for me. Because it says a light bulb, it doesn't focus on the entire object, right? It focuses on only one point. That's why the motion of any point on a Ferris wheel or any point on a rotating object is circular, is not, let's say, rotational. Question number 9. For any point on a spinning object, look here, for any point, let me underline it for you. For any point on a spinning object, on the reference line, imagine there's a point, there's a, for example, light bulb, or there's a seat above the reference line of the Ferris wheel. And I told you reference line means positive x-axis. This is our zero level, right? There's a point on this, let's say, reference line. The distance measured, look here. This is the definition. It starts from here. The distance measured from the center of the circular path to that point. To that point is called what? So, is it radius? Is it angular displacement? Is it arc length, or A plus B? Actually, the point from the center of the circle, this is circular path, for example. This is the center. And let me draw it with another color. I'm gonna, let's say, so this is our reference line, right? Positive x is our reference line. And this is circular path. It says the distance from the center to that point. A point, for example, is located on the reference line, like this. There's a point. There's a light bulb, right? This is a point. So the distance from here till here for this point, actually, from this point, it's called radius, right? R. So radius is the answer, radius. Question number 9, the line that passes through the center of the circular path, the line that passes through the center of the circular path and extended, look here, and extended along the positive x-axis. So it's clear because it mentions positive x-axis. I'm sure you know the answer. So it's a straight line that passes through the center of the object and actually extended along the positive x-axis is called reference line, right? Do you agree with me or not? You know the answer? Did you, let's say, guess the meaning? Did you guess the answer? So the answer will be the line that passes through the and it extended along the positive x-axis is, let's say, reference line. Number 11, it's the distance. It's another definition. It's the distance measured along the circumference of a circle. It's the distance measured along the circumference of it. For example, this is a circle, right? The distance. Think about an object that moves between the two successive points on the let's say, circumference of a circle, from here till here. Initial position, final position, during a time interval. So this curved path or this route is called arc length, right? So it's a distance measured along the circumference of a circle. This is called, is it radius? It's not radius because radius is a straight line. It can't be, let's say, reference line because reference line is a straight line as well. It's a positive x-axis. So arc length is the answer. Guys, thank you very much for watching this video. See you next video and take care.